What if I told you that stress can actually be good for you? Or that testosterone, yeah, the hormone we all link with aggression, can actually make people more generous? I know, it sounds totally backwards, but the science here is just fascinating. So let's dive into the surprising world of how context can completely rewire your brain and your body, all based on the brilliant work of Dr. Robert Sapolsky.
Here's what we're going to cover. First, we'll look at the two very different faces of stress. Then, we're going to bust the biggest myth about testosterone. After that, we'll get into something called the challenge hypothesis, which is all about how context just flips the script. And finally, we'll see how your own brain is the master switch that controls everything.
All right, first up, stress. We spend so much time and energy trying to get rid of it, but what if we're looking at it all wrong? Is stress always the bad guy, or could it sometimes be the hero?
We're all conditioned to think that stress is just bad, period. But, biologically, the line between thrilling excitement and absolute terror is razor thin. Your heart races, your breathing gets faster. The physical stuff is almost identical. So what's the real difference? What makes one feel incredible and the other feel just awful?
Well, the huge difference is between what we call stimulation and chronic stress. Think about it. We actually pay money for short-term stress. We go on roller coasters, we watch scary movies. That's good stress. The kind that really messes us up is that chronic, grinding stress that just never seems to end, like a horrible job or a daily commute that just crushes your soul.
So what's the biological tipping point? It's this tiny almond-shaped part of your brain called the amygdala. According to Dr. Sapolsky, you can have that exact same high arousal feeling, but if the amygdala fires up, your brain flags the experience as negative. It's like the critical checkpoint that decides if you're feeling exhilaration or pure terror.
And speaking of brain chemistry, let's talk about one of the most misunderstood molecules out there, testosterone. We are about to completely bust the biggest myth you've ever heard about it.
You've heard this a million times, right? It's practically a cultural fact. More testosterone means more aggression. Super simple. Except, it turns out it's almost completely wrong.
Dr. Sapolsky just puts it perfectly. Testosterone doesn't create aggression out of nothing. A better way to think about it is like an amplifier. It takes whatever aggressive tendencies are already there, the ones shaped by our social learning and our environment, and it just turns up the volume. It makes the system louder, but it doesn't write the music.
The really crucial thing to get here is that we've had the cause and effect story totally backwards. It's often aggressive behavior that causes a rise in testosterone, not the other way around. What the hormone really does is it just lowers the bar for you to react to something, and its effect depends entirely on what you've already learned is the right way to act in that situation.
So, if it's all about context, how does that actually work? Well, this is where this brilliant idea called the challenge hypothesis comes into play. It explains how the exact same hormone can lead to wildly different outcomes. It was formulated by a guy named John Wingfield, and it's actually beautifully simple. It goes like this. First, your social status gets challenged somehow. In response, your body releases a shot of testosterone. And here's the magic part. That testosterone then amplifies whatever behavior is necessary to maintain your status in that specific game. And this just illustrates the point perfectly. If you're a baboon, how do you maintain your status? Through aggression, right? So testosterone amps up aggression. But what about us humans? Imagine you're at a fancy, high-stakes charity auction. How do you show your status there? By being the most generous person in the room. In that context, testosterone would amplify generosity. It's the same hormone causing totally opposite behaviors.
And this is just incredible. Studies actually confirm this. When people are put into economic games where you gain status by being trustworthy and generous, giving them a dose of testosterone makes them more generous. It just amplifies whatever it takes to win the game you're currently in. So all of this leads to a pretty profound conclusion. If our hormones don't dictate our behavior, but instead just respond to the context, then the ultimate power lies in how our brain interprets that context. You, my friend, have a master switch.
Let me tell you about a classic experiment that just drives this point home. Okay, so you've got two rats. Rat number one, it decides to run on its wheel whenever it feels like it. It's in control. Now, rat number two is forced to run at the exact same time for the exact same duration. The physical activity is 100% identical, but the outcomes? They couldn't be more different. The first rat gets all the healthy benefits of exercise. The second one? It gets all the negative health consequences of severe stress.
Just think about that for a second. The only thing that changed was psychological, the sense of control. Our interpretation of what's happening to us doesn't just change how we feel, it fundamentally changes the biological impact that event has on our bodies.
And this really shows us what truly makes something stressful. It's not the event itself. It's these ingredients: a lack of control, a lack of predictability, having no outlet for your frustration. And this is where our amazing prefrontal cortex can be a double-edged sword. It can spin stories that either protect us from stress or plunge us way deeper into it. So we end with this. If your mind's interpretation of an event can flip a biological switch, one that turns terror into excitement or aggression into generosity, it leaves us with a pretty profound question. You have the ability to frame your world, to choose your hierarchies, and to influence your own biology. And if you have that power, what context